Now that we have an idea of what the idea is behind a Riemann sum, let's make clear exactly what that terminology means, Riemann sum, and let's try and get a formula going for calculating those sums relatively easily. So suppose we have f of x, which is representing a positive function on some interval, let's just say a to b. What is a Riemann sum? A Riemann sum is an estimate of the area of this region under the graph, calculated specifically by tiling the region with rectangles, just as we did in the previous video. Now there are two main varieties of Riemann sum, depending on where you position the rectangles that you're using to do the tiling. In our previous example, our rectangles were attached to the graph on their upper right corner, But you can just as easily attach the rectangles to the graph so that the upper left corner is the one that's attached to the graph. And that would be an example of something called a left Riemann sum. So let's just get a quick sketch going here on the side. We have an interval from a to b, and we have some positive function. Let's say this one. Here is f of x. And the idea is to overlay some number of rectangles to this function, attaching them, in the case of a left Riemann sum, to the function by the upper left corner. So let's see if we can find a formula for the estimate given to us by the left Riemann sum. Now to do this, let's try and consider just some arbitrary rectangle here amidst the tiling. Rectangle not 1, 2, 3, or 4, but just some rectangle over the end that we use for the tiling. Rectangle K. What would be the width? What would be the width of this rectangle? Well, let's use an analysis here of what's going on the x-axis. In total, the distance between B and A on this x-axis is B minus A, since B is the larger of these two numbers. Now, if we use n rectangles to fill up that region, then how can we calculate the width of each of those n rectangles? Assuming that they are all equally sized, and that's traditional, then we will split up that total width of B minus A into n pieces, and that would be the width of any one of these individual rectangles. So here's rectangle K, and it has a width of B minus A over n. Okay, so now we have to figure out the height of rectangle K. And the height is going to be based on the function's output value. So let me write just temporarily, the height of this rectangle will be the output of function f if we plug in the x value of left side of rectangle. So for example, if this is rectangle number 1, the x value on the left-hand side would be a. For rectangle number 2, the x value on the left-hand side would be a plus 1 width, 1 step in the x direction. And in general, for rectangle number k, you can find the x value of the left side of the rectangle by taking the initial x, a, and adding delta x a total of n minus 1 times. This formula will bring you to, k minus 1 times, this will bring you to the left side of the kth rectangle in this triangle, in this tiling. So in summary, if you want to find the area of this region using an approximation by left-sided rectangles, you can sum up, you can add up from your first rectangle to your last rectangle, width of the rectangle, delta x, times height of the rectangle, width times height of all of these rectangles. That is what is going on here. And we'll see an example of this formula at work in just a moment. Now, if you want to attach the rectangles on the right-hand side instead of on the left, then the formula is almost exactly the same. In this case, if I want to attach the rectangles by their right ends instead of by their left ends, the width is still going to be an even distribution, b minus a divided evenly across those n rectangles. The only thing that will change is the height of rectangle k. Here, instead of adding delta x k times, we'll add delta x exactly k times. For example, here is rectangle number 1. To get to its right endpoint, I would have to start at A and jump by 1 step in the x direction. If this is rectangle number 2, to reach that right endpoint, I'd have to start at A and jump by delta x twice in total. So an exact match between the number of the rectangle and the number by which you have to multiply delta x. In sum, for the right Riemann sum, that formula is go from k to n, height, f of a plus delta x times k, times width, delta x, which is given by b minus a over n.